In this video, we are checking the test bench code for 4-bit adder. So just go to Xylem. So already we have designed this 4-bit adder. Okay, this is known as your structural way. So how to write the test bench code already we have seen. So for test bench code, so we should switch to simulation. Go in the project. We are selecting here the new source files for test bench coding. Choose here Verilog test fixtures. We are taking the name is tb underscore adder underscore 4-bit. Next, we are going to write the test bench code for adder 4-bit. So choose your particular component. Next, finish. So here the model it generated that model and end model with inputs, outputs, and instantiation of your particular unit. So this is the inputs, that is of your 4-bit, B 4-bit, sum is the output, that is 4-bit, cout is single bit. We have to call here the same model which is a pre-designed. So adder 4-bit UUT is nothing but that instance names unit under design. Now here it is explicit mapping, or we can say it is naming. So dot A, and this is a. So dot A is the port of your 4-bit and the A is nothing but the actual port in this particular test bench. So over here we just change, or here we just provide the values for your A and B and we are checking it. So you can check for multiple inputs. That means if you are getting that A is 9, B is 7, or A is 8, B is 10, and so on. So let here we are getting that the inputs which are provided in that the first video of this particular 4-bit adder. So we have taken the number is 13. So 1101. Then we have taken that B is 11. That is 1011. So after 100 nanoseconds, we just change here that A and B, and we are trying to take it some another number. Here we are taking it. You can consider that any 4-bit numbers. Let us assume that we are taking that first is 13, 11. Then let us assume that 9, 11. Here we are taking that 13 and let take that 110, 13 plus 13, and the last one we are taking that, let go for that 110, 14 plus 8. So save as file, then check on the simulation view. We should have a TB. Click on this TB underscore adder underscore 4-bit. Double click on simulate behavioral model. Test bench is very much simple than the previous one, as already we have seen in the previous practicals. Here we have to just provide the input values for your A and B. It is failed, that means there is some errors. Let's check what the errors here we called as. Okay, so we have to write that 40B base. We just forget here the base 40B. Note here the number formats. Let runs once again. Now check it. It is done, successfully completed. New window of waveform will be open. Yes, zoom to full view. Let's check. If we are not understanding the binary, so we may check their decimal values. Now note here that cout, this output is nothing but the combination of your Cout and sum. So what here we are getting, the result is the first number, that is 1101 plus 1011. The sum is 1000 and the Cout is 11. If you are taking the combination of these 5 lines, then you are getting that the actual result, and this result is nothing but the 24. Similarly, here we are getting that 1101, that is 9 plus 11. So you are getting that the Cout is 1 1 0 1 0 0. So 1 0 1 0 0, that is 20. In the same way you can find for this 13 plus 13. So you are getting that, sorry, 1101 plus 1101. So you are getting that 11010, that is 26, and so on. So in this way we can run these simulations. Now if you want to combine the result, or if you want to check their decimal, so we can make one change in our program, and that change is here. In place of taking Cout is separate, okay, so here we can say that it is a 4 down to 0. So final Cout is nothing but S of 4. Only we make this change, save as. There's some syntax error, okay, here save as, then synthesis it, and do the change in test bench code also with respect to that. There is some error, let's check what the error is here. Assign S is not declared, okay, here it is small capital, so take a note that use only either uppercase or lowercase. Wait for, yes, synthesis is done successfully. Now change in the test bench code. In place of Cout, here we are not taking the Cout. So in place of Cout, we just take it 4 down to 0, that is combined result of your Cout and sum. Save this, then check for the simulation. You can just close this previous waveform window and rerun it. Zoom to full view. Now in place of Cout, there is a 5-bit sum, 4 down to 0. Here you can check it, the result in unsigned decimals. So change their radix, change here the radix for B also and sum also. Now check it. Okay, so signed here, it is taken as unsigned. Okay, fine. Now 13 plus 11 24, 9 plus 11 20, 13 plus 13 26, 14 plus 8 22. So we are getting an exactly correct result. So here successfully we design 4-bit adder. It is also known as your ripple carry adders. You can take a print preview for this particular waveform output for your practical channels. So thank you very much for watching this video. I hope so you understand all the ECD practicals. Thank you.